Now we talked about the intercept form and the standard form of the quadratic equation. In terms and we wrote the intercept form in terms of roots, which is that if alpha and beta are the roots of the quadratic equation, then we can write the intercept form as a, which is a constant, x minus alpha and x minus beta is equal to 0. Similarly, in terms of the roots, we wrote the standard form as x and then minus alpha plus beta plus alpha into beta is equal to 0, right? But there is a different way we can write the intercept form and the standard form, and this is basically called the FOIL method, right? So we will write the intercept form as ax plus b into cx plus d is equal to 0. I will explain it further through an example as in how it is useful. And similarly, we can write the standard form as acx square plus ad plus bc into x plus b into d is equal to 0. So we can also write the intercept form and the standard form in these terms, and then it becomes easy to compare, to convert from intercept to standard form and from standard form to the intercept form. Let's look at some examples. We have to convert this equation written in the intercept form to the standard form, and we can we can compare this to ax plus b cx plus d is equal to 0. If we compare, we found that a is equal to 1, b is equal to minus 2, c is equal to 1, and d is equal to minus 4. Now we said that in similar terms the standard form will be acx square, right? This is a and c, both the coefficients of x, so multiply them, acx square, then ad plus bc into x, then the product of bd is equal to 0. So ac, we know that it is 1, so x square plus, now ad is minus 4 plus bc is minus 2 x, and then bd, which is 8, is equal to 0. And if we further solve it, x square, and it becomes minus 6x plus 8 is equal to 0. So this way we could easily convert the intercept form to the standard form. Now in this question, the equation is written in the standard form and we have to convert it in the intercept form. Now if you compare this to the standard equation we talked about, and we wrote that is acx square, right, and then ad plus bc x plus bd is equal to 0, right? So we have to compare both of these. Now if you observe it well, if you multiply this, right, the coefficient of x square and the coefficient of this constant, we get a, b, c, d, right? And if you multiply these two, you also get a, b, c, d. So here we can, if we compare this, we can say that AD plus BC is equal to -4, and ABCD is equal to 4. So from here we can easily conclude that AD and BC must be -2 and -2, right? This is the only way that these this number satisfies both these equations, right? So here we could easily find that AD is equal to -2 and BC is equal to -2. Okay, now we can write this as x square minus 2x minus 2x plus 4 is equal to 0. Okay, because if we compare this, the coefficient of x were AD plus BC, and AD is -2 and BC is -2. So, and if we take the common now, right? So if we take common here, we get x minus 2, and here if we take the 2 common, we get x minus 2 is equal to 0. So we get x minus 2 square is equal to 0. So 2 is the repeated real root of the given equation, and we were able to write in the intercept form, which was x minus 2, right, is equal to 0. We could write that in a more direct way as we learned in school, but this is the more mathematical way, the FOIL method. Okay, we can have one more example to have clarity. So let's say we have the equation x minus 25 is equal to 0. Okay, now if we compare to the equation AC x square plus AD plus BC x plus BD is equal to 0. Here we found that AC into BD is equal to minus 25, and AD plus BC is equal to 0. From both these equations we can conclude that AD is equal to 5 and BC is equal to -5. So we can write this equation as x square plus 5x and then minus 5x minus 25 is equal to 0. And if we take the x common here, x plus 5 and then minus 5 here, we get x plus 5 here. So we get x minus 5 and then x plus 5 is equal to 0. Hence this is the intercept, and so 5 and minus 5 are the two roots of this quadratic equation. So that's how we change from intercept to standard form and from standard form to the intercept form using this FOIL method, comparing the standard form to this and from to the intercept form to ax plus b and cx plus into cx plus d is equal to 0.